And welcome to another Austin Python Meetup. Today we have Johann West, who's going to be talking about reimagining data with machine learning. And with that, I'll hand it over to you, Johann.
Yeah, let me share my screen. So is this coming up full screen for everybody? This looks good? Yep. All right, sounds good. Hey everyone, I'm Johann, and I'm one of the co-founders at PureML. Here to talk to you guys a little bit about like the concept that we're trying to tackle. It's a lot of machine learning, a lot of data science. So just curious, has anyone here built a machine learning model before? I know Python's kind of like the data science language. Jacob, I know, yep, for sure. Yeah, that's awesome. Yep. Thanks, Cameron. And so, yeah, again, I want this to be like as interactive as possible. So feel free to interrupt me at any point. And if you're not comfortable with that, I'll make stops throughout to like kind of ask for questions, gauge the audience. And so, yeah, so like what are we talking about here? So PureML, the product we're trying to build is essentially using AI agents to do machine learning dataset pre-processing. And so that brings us to our talk. Let's dive in, reimagining machine learning datasets with artificial intelligence. And here's a link to our website if anyone wants to check it out while we're going through it. And just like throughout the presentation, if we pique anyone's interest, we're looking for testers to test this out. So if that's something you want to do, if you're someone with data or just likes to build machine learning models, please hit us up. We have a waitlist form on our website. And yeah, so starting with like kind of question that PureML was kind of born from, and it really sets the stage for like what we're going to be talking about today. So what if we could use AI to intelligently handle machine learning dataset pre-processing? And if you're not familiar with ML, don't worry. We're gonna kind of like do an overview real quick of dataset pre-processing, the process for machine learning, so we can all get on the same page. And so I'm a machine learning engineer again, and so this is kind of the process I follow for building a machine learning model. It differs from place to place, differs from model to model, whatever your problem context is, it can differ, but basically, a lot of times you start with your data collection. And so, for example, right now, I'm finishing up building a model, which is, I work for an insurance company, Haggerty, that does car insurance for collectible vehicles, like classic collectible vehicles. Like think of like an old DeLorean or something like that. And the model I'm building is to predict if an insurance quote will convert or not. So if a customer will purchase it. And so data collection for that might look like looking at all the data that we have access to that might be relevant to predicting if a quote's going to convert or not. So customer data, data on the quote itself, vehicle data, all those things. That's the first step. The second step is to look at this data and perform analysis and find out exactly like which data points are going to be good or not. One, for example, like we're combining a lot of different data sources here, so we have to make sure they line up, make sure we can like key off the right primary keys and foreign keys, stuff like that. We have to make sure there's a distribution that's contextually relevant enough to the context that for the problem we're trying to solve. A lot of stuff like that. We have to make sure it's not so unclean and so dirty that it's not going to be useful. And then once you do that, do something that a lot of people call data pre-processing, which we'll dive into that more in a second. And then once you have all that done, you train your model. And so for what we're trying to do is really focus in on the data pre-processing step. And so what is dataset pre-processing? There's a lot to it, and it differs again from machine learning problem to machine learning problem, but two like kind of core aspects that you will do in 99% of situations is data cleaning and feature engineering. So data cleaning, companies like to think not, but in my opinion, the vast majority of companies have pretty unclean data, and this is hard to avoid. There's so many processes, so many sources of data you're pulling from. At some point, there's going to be a bug. There's going to be something that happens that results in data being unclean. Whether there's null values that shouldn't be there, or it's things like inconsistent values. By inconsistent values, I mean like, say you have like, we're talking about like HR data. Say you're building a model for HR and you have a data set of employees. Say you have a column in your data set that is department. So a value for that might be sales department. You might have another value in that column that is like sales DEPT, just like the abbreviation of department. And while that means the same thing as sales department, it's not actually the same string. So if you feed that to a machine learning model, that's going to see, like, let's take a machine learning model framework like XGBoost. It's going to see those as two different categories, sales department and sales DEPT. And what you usually do to like handle things like inconsistent values, you might write like a Python script for like regular expressions. Sorry, real quick. Someone okay. I don't use Google Meet a lot. Is this in-call messages the right place to look for questions if someone wants to post one? Perfect. All right. Thank you. Yeah. So as I was saying, you want to correct those inconsistent values, and that's a lot of like writing Python scripts, regular expressions, stuff like that. And so yeah, that's data cleaning. That's one big foundational pillar of data pre-processing. And the second one we want to talk about is feature engineering. And this is a pretty broad term. It can mean a lot of different things, but a lot of times it's creating new features for your data set based on the raw data that you do have. And of course, the goal here is to increase the performance of your model. And a lot of this is like features that are aggregation. So like if you have a numerical column of data, and also real quick, should have said this at the start, just go over a little vocabulary. If anyone's not familiar with machine learning, features is the same thing as a column of data essentially. So when I'm saying features, that's one column in a tabular data set. And so you might be looking at one feature or one column of data. It's a numerical feature. And you might want to take like the average of that feature and use that as an entirely new feature that could provide value to your model in a lot of cases. It's a lot of aggregation, like averages, modes, stuff like that. And then it's also a lot of looking at different features and combining them in some sort of way. So it could be like a time series thing. Like say you have, let's go back to the HR department, the HR example. Say you're looking at like sales employees. Say there's a column of data that is average time on call. You might want to like build a feature that's like average time on call last 30 days, last 90 days, last year, stuff like that. And essentially like taking your data, transforming it in different ways. Or you could be looking at like and creating an entirely new feature that like takes into consideration other features, like going back to the HR example again, say you have two different sales departments. You've got sales department 1 and sales department 2. You might want to make another column that is like type of employee that says sales. Whether they're in this department or that department, they're a sales employee. And so that's feature engineering, essentially just creating entirely new features. And so the question that we're trying to tackle is, could AI do this? Could you use AI to do data cleaning and feature engineering, data pre-processing? Right there, I'll do a stop. Any questions, feel free to come off mute or post something in chat. Comments too, welcome, anything. All right, I will move on.
I have a comment. I'll say that we're also trying to do this at my work.
Yeah. Are you a ML engineer or data scientist?
Just software, but we work with a lot of data science.
Absolutely, yeah. Like data cleaning is something that like is a problem that expands like so much farther than machine learning. And so, yeah, like right now we're focusing on like, how do we make this work for ML, which is like a huge challenge in itself. But like, yeah, like implications here, and we'll dive into like what's possible here soon. But like a big point of this is like, I want to encourage other people. We're using a very agentic approach, which like we'll explain why makes this very potentially feasible to do. And so like definitely there's a ton of practical applications of that, not just data cleaning and not just ML. So like if anyone wants to check out agents, I'm a big proponent of that, and I highly encourage them to. Anyways, so why do
one other comment. This is also the cleaning part. It's the part where the reason why I guess Jacob knew I'd be interested in is he must remember me complaining about how much time it takes versus I want to get on to do the machine learning part of the problem. And then like the data cleaning part is just a never ending, potentially never ending black hole of work to do. It's like the onion peeling it back. So
yeah, I probably spent a good like pretty much the entire quarter building the model I'm working on right now, and so much of that has just been cleaning data. And actually just got off a meeting today to like I have to go back and like clean some more stuff. So yeah, it's definitely a big pain point for data scientists, and yeah, so I think you'll like kind of the ideas that we're going to talk about, because there's a lot of potential here to make that much easier.
Cool.
And so essentially, to answer this question, could AI do this? We have to understand, why do data scientists have jobs? What can they do that allows them to do this data set preprocessing? Well, you have to like understand the domain that you're working in, and also the business context that you're working in. You have to understand what problem your ML model is trying to solve, and that's going to help inform how you should clean your data, what you should impute null values for, what values mean the same thing, business context there, stuff like that. And yeah, like I said, that helps you handle null values. And also you need the context to understand your features, what they mean. And that's going to allow you to do that feature engineering, combine features in different ways, create new features that not only make sense, but you also have the understanding to make those features an improvement to the model you're going to make. And so Chris here, Chris is actually my boss. He's an excellent data scientist, and he has all these qualities. So if we're going to have AI do this, essentially, like, we need to replicate Chris. We need to make Chris have the domain knowledge and business context to be able to do all these things. And so that's kind of one of like the core philosophies where like that's kind of like driving our approach to solving this. Is context is everything in this challenge. It's getting the context from the user, providing that to an AI system, and that's the key to being able to approach this data set preprocessing that we want to do. And so again, business and specialized domain knowledge and context is what the AI lacks. AI already has general knowledge for pretty much like every domain out there, at least like a top level of it. It can perform excellent on every standardized test out there. It can pass the bar exam, everything, can answer anything about anything. But it doesn't have specific domain context if you're working in like a really specialized context, like maybe it's internal business knowledge or internal business domain knowledge. That's something AI won't have. But another thing that's helpful for this approach is this is a technology that's like growing and growing as the models get better and better every day. The ability to retain memory across an entire project. And so like being able to, one, retain memory in your prompts And so in your decisions, it knows what decisions it's made before the AI does. It knows the context it was given before. And also things like RAG and like vector databases. You can provide context, and if you can store that in a place where the LLM has access to it, and so anytime it thinks it needs to make a decision, it can go pull that information. That's something we can already leverage. And again, like, ask ChatGPT any data science question, it's going to give you a pretty solid answer. And so it's already got like the technical expertise for like the technical side of data science.
So Johann, the part of this slide that I like the most is, or that I think is the most innovative, that's kind of like a lightning bolt to my brain, is the part where you say ability to retain memory across a project.
Exactly.
So that would be so helpful in a lot of different ways. If you mean by that what I expect you to mean, I guess.
I think you're getting it. Yeah, because like ChatGPT actually has like pretty decent like memory retention now. But like, say if you just open a new ChatGPT window and like you give the question, it doesn't have like any memory to like all the steps you performed before you asked that question. And so like that's the context there. Again, the context is everything for this problem. And so like having not just a memory, a long-term memory, and one that can like, for example, we'll get into the demo, but the demo we're using for kind of like the context that we're talking about, we uploaded like 10,000 pages of like PDFs, and like the AI agent that we're using has access to that. And whenever it thinks it needs more information, it can go query that vector database and pull that information at will. And that's a huge point of like that memory that we're talking about as well. And so like the question is like, what if we could really effectively give AI this context to make better decisions, better informed decisions, do this data set preprocessing? And so the approach that we use is the agent approach. I love agents and totally willing to talk about just agents in general if they want to. And we use agents. So basically we have a entire system of agents that we provide business context to these agents. We'll get into exactly how later, but if you can provide this business context, these agents can then make these informed decisions, this business context informed decisions on how to pre-process your data set, how to do that data cleaning, how to do that feature engineering. Very similar to like a human would. Think of it like an AI agent with all the general knowledge it has. It's like a really, really good intern that just started the job. It doesn't have the business context yet. It doesn't know how the business works. But once you give it that context, if you can give an intern a small task with a little bit of business context, a good intern can do a pretty good job with that. And so the possibilities with this, 3 things that we're focusing on right now for dataset preprocessing is context-aware null handling, intelligent feature generation, and data value consolidation. And I'll dive into like a demo now, and we'll kind of like really walk through deeper what each of those mean and like how that's being executed and the way we're doing it. Let me stop sharing and pull up a different screen. Also, that's a great place to stop if anyone has questions. I can pull the slides back up if they want to go over anything.
Yeah, we got a question. One sec.
So, null handling,
Yes.
value imputation, data consolidation, feature generation. These are all sources of bias to your model. So when you go through your discussing this, if you could talk to or speak to how you are not inducing bias in your models.
Yes. Interested. Could you like provide like an example of like the bias that you're referring to specifically? Like,
well, okay, context-aware null handling. You use in on your website. You talk about people doing averages, and averages have the virtue that they put absolutely no bias because they are in fact average value. right?
Yeah.
So there's no bias from them. Of course, what we really want from our machine learning models is for them to be able to work with noisy data, including nulls, and that they should in fact expect to have garbage in, and they're supposed to find the bloody patterns anyway.
Yeah.
So when you are talking about fixing all these things, which is a laudable goal, and I'm not trying to rag on that. I just want to make sure that I understand what you're going to do to my models, because you will induce bias.
Yes, absolutely. Like, you're completely correct in that, and I think you're gonna be able to pick apart like the demo pretty well, because it's what we're trying to accomplish is it's an entire paradigm shift, and there's still a lot of work to do to prove that it's a concept that not only works but like is going to be useful. Like, that's the whole question of machine learning models. It's like it's easy to build an ML model, but it's really hard to build a useful one. And so like it's an entire paradigm shift, and you'll see why once we get to the demo, because it's something that like you wouldn't want to do normally for machine learning models. One, because it would be impossible to do it well as a human. And yeah, so like let me dive into the demo so you can see what I'm talking about. But yeah, like bias, it's one of the biggest challenges. Bias, hallucinations, because we're going to be imputing null values that based on the context that we have for the row. So it's not like an imputation like putting in an average or putting in like -1. It's an imputation that is essentially like if an intern went through your data set, if they went in and filled in values they know were supposed to be in certain places that weren't, that's kind of the null handling that we're talking about. And there's a lot of potential for bias there, but that's one of the big challenges. Let me share my screen. All right, everybody see the demo? Yep. All right. And I can't see. Let me pull this over real quick. Sorry. Move this tab over so I can see the chat as I'm talking.
Don't worry about the chat. We'll read it to you if there's anything.
Okay. All right. All right. Welcome everyone to Pure ML. And so kind of user flow here is this is the data set that we'll be using, that we'll be kind of like walking through like this is an early prototype of what we're imagining. We started only a month ago. And so this was essentially our first proof of concept. And yeah, so you'll kind of see like realize what we expect, how we expect this to work. So like the first step we want the user to do is to upload context documents, we're calling them. So the way we expect this to work is you have a data set that you want to train an ML model on. As many documents, PDFs, other data sets, stuff like that you can provide, that can provide business context and domain context to your ML problem, the data set you're trying to work with. That's the more the merrier, because in this process, we're using a multi-agent system, and those agents, to make the best informed decisions they can, they're relying on their general intelligence, and then also any context you provide them. And so like, for example, here is a data set of cars. What we're using for this data set is, we already like pre-uploaded it for this demo, but it's 10,000 pages of car manuals from various cars from 1945 to 2020. And so for a car data set like you have here, car manuals are going to provide good context, because in car manuals, if an agent can digest and understand car manuals, it can understand how cars work, models for certain cars, what types of cars are what's a truck, what's an SUV, typically which brands use what engine, stuff like that. And so, yeah, for this data set, we've got a bunch of features: brand, model, model year, mileage, fuel type, engine, transmission. And then price is going to be the target variable we're looking for. And so that means it's going to be a regression model predicting price. We'll use R squared for the evaluation metric, and we'll just use XGBoost for training framework. And with that, let's dive into the first thing we mentioned before, which was null or missing value handling. Intelligent context-informed null handling. And so if you look at rows 1 and 2, you might notice that we have null values here. And normally in machine learning, how might you go about doing this? You might just impute a value for this. You might leave it as null. You might put -1. You might put just other for a categorical feature like this. Or you might have an intern sit there and slave away going through thousands, hundreds of thousands, maybe millions of rows of data, if that's possible, trying to impute for these null values, trying to figure out. Because I don't know how many people are like, if you have some knowledge about cars and stuff, I'm sure you can guess that like Silverado, that's a Chevrolet. That's the brand for Silverado. And that's something like your average intern could probably know, or if you ask them to, they could go look it up. And so like, again, that's kind of the idea. These AI agents, think of it like a really good intern. And so what the agent did here is looking at the model fields, it can identify that like a Silverado, that's a Chevrolet. And in LSV8, I don't even know what that is, but it was able to correctly identify that's a Lincoln based on the model field. So the way this works is right now the process, and this is definitely something we're iterating on constantly, but for this first demo, it was essentially going through each column, and to fill the null values, it was looking at other columns of data that it determined would be relevant to potentially fill values for the column of data it's looking at. And so for this one, it selected model, because using the external context, those car manuals, like there's so much data in that. And also just its general knowledge, like Silverado Chevrolet is something GPT can answer. Going through and filling all those null values. And then, and kind of like touching on your question, George, like with bias, you don't want to be imputing values if you aren't confident enough that you can determine those values. Like for example, you'll look at row 4. These are still null. And that's because in row 4, both brand and model were null. And so with the remaining features it has, there's nothing here that can really indicate what the brand or the model for this vehicle is. It has engine, and it could potentially determine brand. Yeah, go ahead, George, if you have a question.
I have a question. Is there any human in the loop where I can like have an actual intern just to prove these things?
Absolutely. That's not in this first demo, but that's something we're actually working on like right now, is going through and like having the human in the loop so you can accept or deny any of these null values. And another thing we want to provide is having metrics for all this. So like having a confidence score. How confident was this null value imputation? And something that's easy to do that we're doing is like having like a temperature essentially. So like how aggressive is the agent system going to be for imputing values? Is it only going to impute if it's almost as certainly confident as it can possibly be? Or is it going to be as aggressive with it as possible and just fill everything? That's definitely what we're taking into consideration.
Another question. Can it, do you have to assume that you know all your categories, or can it make new categories?
That's let me pause on that because that's really relevant to the next page I will show you. Yeah.
I'm parking lot it for after. Don't worry.
Yeah. It's almost exactly what the next page is. Yeah. So,
Sorry, one more question.
yeah.
So a problem that I have at my company is sometimes the data sets lie to us. Like it just contains inaccurate information.
Yes.
So in this case, Silverado is a Chevrolet, but just for like my data set, maybe there's an edge case that I just know because I work at the company. Oh, if it's like a 2017 Silverado, then it isn't. I don't know cars, so that's a bad example.
Yeah. Oh, yeah. But I know exactly what you mean. There's certain instances where you know that, like, oh, it can't. Like, that's something that, yeah,
that would be wrong. So I love the idea of like your next phase is like, hey, I'm going to actually show each of the transformations I made, and the intern can go and approve them. I would love it. Is there a phase at that point where I can interact with your agent as an agent? So instead of uploading a PDF, can I then tell your agent, oh no, this edge case actually relates to this business use case and your correction is incorrect? Can I build domain knowledge as I'm interacting with your pure ML system?
That's a fantastic idea. And it's something that like we've been toying with, is like letting users essentially, like, because all these agents, they all run off prompts. And like the way we do it is we have a ton of agents, because each agent, like these systems work best if you give these agents as small as an individual job as possible. And then you combine all these essentially like individual workers together to produce like one final product. Like one agent is going to be determining which columns are relevant to fill the nulls for this column, like a little job like that. But we have toyed with the idea of allowing the users, finding some way to abstract that and allowing the users to like insert their own prompts. And that's actually a fantastic idea. And it doesn't even have to be an own prompt. It could be like, you could have just like a little, like an input box, like additional, not like additional information. Like if you want to specify something, that's going to get fed into like the prompt in the agent system where it should be. And actually, yeah, I've not thought of it like that, but like, yeah, it's honestly probably going to steal that.
Yeah, and just like one more follow up on like your data set being unclean, the documentation is also going to be unclean.
Yes.
So the initial 10,000 PDFs are going to be all outdated and contradictory. So I want like an additional step to talk to.
Yeah. Sorry.
Yeah. That's again like another big obstacle there. And the kind of philosophy that we worked with there was like, if it's in your business and if it's something that like you would give again like to an intern, that's the stuff we want. Anything you would give to someone you're onboarding, that's how we want people to think of this system, is it's like really, really, really good interns that can do this stuff. And yeah, that's a big challenge. Like, cause like, it's just the way people are going to use this, like, is they're going to just like upload just like a huge folder of documents, not go through them one by one and like parse them and make sure like this one's like, oh, this one's old, that one's not relevant anymore. We changed the system. And so, yeah, that's a big challenge, but that's, again, human in the loop is our biggest protection. Because all of this is like trying to speed up the data preprocessing process, and having human in the loop there, while still is like human input, is critical to like make sure that like whatever mistakes are made, because there are going to be mistakes. The goal here isn't to be 100% perfect. It's to build a better machine learning model than you could build without it. And so any mistakes that do happen, going through and correcting those.
There's a comment from Josh. Seems like DB normalization is a key for automating this. I'm not sure it's a question, but it's a comment.
Giving normalizations, you said, Jacob?
DB, database normalization.
Yes. Yeah, that's not in our next version coming up, but like all that's like, there's so many parts of this that can make this as powerful as possible. And yeah, stuff like that we definitely want to consider. All right. I will move on to the next one. And
A question, if I can interrupt.
yeah, yeah.
How are you guys considering scaling this? Because there's different strategies people have used to put context into models. Some people like Pandas AI will put like just the first row and the column names, but then do all the processing with some kind of engine like Pandas.
Mhm.
But if you put like all the data raw into the model, that's kind of too much context, and it's easy to have it not do so well. How do you guys approach that?
Yeah. So if let me make sure I'm understanding your question correctly. So you're referring to like scaling, like we have huge data sets like with millions of rows. Like how do we make sure we're scaling like our intake of context? So like any agent is not going to be able to like look at millions of rows and remember everything perfectly, right? Is that what you're asking? Or
Right. Yeah. Yeah. How do you kind of scale to those large sets of data?
yeah. And so like that's like where we break down, like that's going back to like the architecture of these agents, where we may call it like just agent null handling. You might think it's one agent, but in reality it might be dozens or even like hundreds of little agents doing all very specific tasks. And so like you might have one agent that's the expert on the metadata for this data set. You might have one agent that's the expert on like one column. And if you can split all those up, it kind of builds like a directory of information for your orchestration agent. The agent at the top level that everything flows to and from. That's kind of like how we're approaching like issues like that, which is like we have so much data here. How are we like understanding it all and building like structure for it all? Does that answer your question, Greg?
So it sounds like you're putting a lot of emphasis on the orchestration engine.
Yeah.
What kind of data model does that orchestration have? Is it, some kind of like context graph or something like that?
Yeah. So big tool, like agents work really well with like vector data. And so anything we can put into vector data that can be represented well by vector data, we do. So like those context documents, anything text is going to be amazing for vector data. Something like the actual data set itself is not going to be represented amazing by vector data because you're going to lose the structure of the data set if you do that. And so right now we're literally like we're keeping it in actual like pandas data frames and having the agent navigate via like pandas essentially. And so we build tools for these agents like to essentially use pandas, and that's how they navigate, which is not a super scalable. Like if you're training a model with like 10 million rows, that's going to take a while, which is like that's still something we're like deciding, because like that might be fine if it takes like an hour to do this, like just sit there and load for an hour. For an ML model that works well, that might be worth it because it may save you like a month of pre-processing. But yeah, to answer your question, right now we're just using pandas, but going forward we are looking for more scalable methods for that. All right, if no one has anything else, I will we'll dive into the next feature, which is we're calling it data enrichment. And so this is essentially like feature engineering. And I was calling you George, but it might have been someone else talking through George's mic, but someone had the question of like, can you create new features to essentially inform your null handling? And that's kind of what we're doing here. And so we've got like all these features that we started with. We have our values null handled now. And then we have the AI agents look at the data set, take in all that context, take in all the external context, and decide from this data I have, what's new, not just new features I can build from this raw data, but what's entirely new synthetic features I can create. what I mean by that. And so like we have brand model, all these are original ones. Car body type, horsepower, country of the manufacturer, and is it a luxury vehicle or not? These are all entirely new generated features. And they're not just like aggregations of existing features that we have. They're entirely new. And like, so how's it doing this? Like the key here is like, again, looking at the context you have. And if you're confident that you can build something off of that, the agent does that. For example, car body type. Looking at the model column here, Cooper S base, the agent knows that a car like that is a hatchback. Silverado is a pickup. I'm not familiar with Genesis, but F-150, it failed to do that one. But 5 Series sedan, stuff like that. And like horsepower. This one, it's not making a decision. It's actually parsing the horsepower out of the engine field here. And so we can take a categorical, a feature in a categorical format like engine, where it's just a string field. And we don't have like the power of that like linear numerical distribution that a numerical feature would have. And we can parse out the horsepower from that and then use that as a numerical feature. That's something we like. This one would be super powerful to add. Country manufacturer, and is it a luxury vehicle or not? This one's a Boolean. Both of those can be determined from looking at the brand of the vehicle. What's the brand? Mini Cooper, that's built in the UK. It's not a luxury vehicle. Lincoln is a luxury vehicle built in the USA. And this data set, it's really easy to do this with because it's like, this is stuff that like a lot of it is going to be in the agent's general knowledge. So like agent's going to know Lincoln is built in the USA. So it's really easy to do that. The challenge, of course, is doing this with real data, internal company data, stuff that like you're going to have information that is not public knowledge and making decisions off that. And so while this one's a lot of general knowledge, what we want to do is like have it be able to do it with by examining the existing context and making conclusions based off that. And like what I mean by that is like you could, like for example, let's go back to null handling. I know there's a product out there, a couple of them that like essentially do like meta machine learning model null handling. And so it's like building a machine learning model to handle the null values in the data set you're training for a machine learning model. I know it's a mouthful of data science terms, but instead of doing that, something like that, where we like do it entirely mathematically, if you can have your agent system contextually understand your data set, understand the connections between everything from more of like a human perspective, I guess, then you can make conclusions on what features you should add. And that's one of the really powerful things we're really hoping to achieve in a very effective format. Any questions there? Sorry.
Sounds good.
All right, I will move on to the last one, which we'll showcase, which is value consolidation. This one's pretty easy to understand. So this is going back to like when we have inconsistent values in our data set. So like for this data set, we have Chevrolet here, but then up here we have Chevy. Everyone knows Chevy and Chevrolet, that's the same thing. That means the same thing. If you feed it to the machine learning model framework as is right now, it's going to see those as two different entities. And that's not what you want. And so what this is doing is it's going column by column. For all the unique values in the column, it's going to essentially create mappings for them. So for Chevy, it's going to see Chevrolet and it's going to see Chevy. And then it's going to say, okay, Chevy and Chevrolet are the same thing, so they should be mapped together. So we have, and then it's going to pick the best value to replace all those mappings with. So Chevrolet's the best value. Replace Chevrolet for any time we see Chevy. And you
Is
can
that-
also, yeah,
Is that
go
like
ahead.
is that like a logistical map, like a rule, like a map you can see and interact with, or is that
Yeah.
just like it's going to implicitly just do all that?
That's the easiest one to do human in the loop because that's super quick. We create the mapping. We don't have it here, but that's what we're working on right now. We create the mapping. We present the mapping back to the user. They can edit the mapping. So they say like, oh no, this one shouldn't be Chevy, Chevrolet, and Mercedes shouldn't be grouped together. Take Mercedes out and put Mercedes with Mercedes-Benz because those are the same thing. So yeah, like this one's like really, this is one of our core ones because it's super easy to get right. And as long as the user is willing to look at that mapping and look over and say, yeah, that's correct. And so, yeah, so row 10, that was Chevy, got replaced Chevrolet. And the whole goal here, again, is to produce a better machine learning model. And so like that's one of our great leverage points is we have a metric to actually like determine if our data sets are actually making better data sets. And the data sets that our first prototype developed, which is the ones you saw, putting that through XGBoost, through an AutoML process, we use Flammel and got better R-squared values slightly, but it's a proof of concept. And this is like what we're trying to build off of. It's this concept that you can have better data sets with an AI agentic system, determining where to make improvements based on context that you give it, to kind of make it like a really, really, really good, while context limited intern. And so we want users to be able to like export these models and use them as they please. And yeah, that's pretty much it for the demo. Website's down there again, pureml.io. Looking for test users. If that's something anyone's interested in, please leave put your name and email in the waitlist form on the website. And yeah, any more questions?
I have a question.
Yeah.
Do you guys do data ops as well? Like, do you have an audit trail for these changes? Like, do you save different data sets?
Absolutely. Yeah, that's definitely something we want to do, is like being able to trace everything we do and provide that to the user. Again, this is a very early prototype. We don't have that quite yet, but it's definitely something that's on the docket to do.
Awesome. We have another question.
Yeah, so my question is, for the base data set, did you impute that data? And like, how did you impute it if you did?
You mean for like null values?
Like the base data set you're like comparing against, like, what did you have an imputation strategy, or did you just like leave it unimputed?
Yes, yeah, that was just left unimputed. So it was just the base data set as you saw it on the first page, and then versus like the final one with all 3 steps applied.
I got another question. So when you do, can you do this mapping from, what if it's like a bunch of different, totally, not like, the mapping sounds cool because that's like rules. Those are rules. But like, what if you have a long strings and you want all those strings to kind of match to a category?
Okay, and so like, would you be replacing it in
like
that?
Strings, like it took out 175 horsepower, right?
Yeah.
Now, could you put all of those into a category of like large, medium, small?
Yeah.
Maybe not even that would be kind of easy to do with.
Like, that's a really good idea, because like that would be a really good. Are you saying like that's something like you want like the user to determine, or is that something you're thinking like automatic?
Well, it should try to go automatically, and then a user should just look through the rules.
Absolutely, human in the loop. Yeah. That's not something we've considered, but that's a fantastic idea, and that's something that probably would work really well, because it's, again, like one of those easier things with rules that the user can clearly see and edit if they need to.
Go for it. So one more question. So at least like the data that I see in my job, a lot of time it's like not in tabular format to begin with. But, like oftentimes it's like raw text or like raw images or like some combination of like inputs.
Yeah.
And like typically like my job as a data science, I look at the text, I look at the image, and then based on that raw data, I extract features. So it's not necessarily like I'm extracting features from a table. I'm like extracting features from like the raw input. So do you have something that could maybe work on an image or work on like a paragraph of text, something like that?
Yeah, that's actually really interesting. You mentioned like the images. For the raw text, I haven't thought about that one a ton, but the images we have, the images, like there's already a ton of like AI tools out there that can like I know one that's like for essentially labeling images. And so if you have a bunch of images in a data set, you can create labels from them and then use those in a tabular data set for a machine learning feature. That's something we're really looking at implementing because it's kind of like, that's something that like you don't have when you're normally doing ML. And so, yeah, that's something we're looking forward to. Did that answer your question?
Yes.
Yeah, I think we're good on the in-person side. If anyone online has any questions.
Anybody?
I have a question, if you don't mind.
Yes, of course.
Yes, my question is it like you can access it only through the website, or do you plan it like to be Python library? Is there anything like also the question, for example, at some point right before the training the model I see and I think like, oh, I can do here more. Can I grab the dataset that you already created, load it to my computer and continue from over there?
Absolutely, yeah. Yeah, like if you don't want to do like the automated AutoML process, like taking that out and like configuring your own like hyper parameters. So right now the plan is to make this like a live like SaaS product. Haven't really thought too much about a Python package, but that is really interesting because that's something you could provide free and then like potentially have like a freemium tier thing for it. One big consideration that we know like users are going to have is like uploading data, like those context documents. Like I know businesses are not going to be jumping at the idea of uploading a ton of internal documents, especially if like they don't have a good way of like checking if anything's like potentially like business secrets or stuff like that. And so SaaS potentially like locally hosted, like a desktop app you can download, stuff like that. And so you can keep it upload your own environments, keep everything condensed in your own sandbox. So there's no external data going to like our servers or anything like that. That's kind of the plan right now, but again, early prototype, still working through the weeds of all the details like that.
Thank you.
Thanks for the question. Anybody else?
As you've been making these agentic workflows, is there anything that's surprising as you combine together different agents that you kind of learned in the process of building agents?
The most obvious one is it's like it works a lot better than like I first expected. I haven't done it like a ton before. I've played around with it, but like building like a really intense system like this where there's like so many moving pieces. Agents are really smart. They're really good at like they understand a lot more than you would expect them to. And especially if you have like if you're passing context between things, and prompting is everything. That's one thing. Like a good prompt is gold, and you can have all the other like traditional programming in there, but if your prompts are bad, it's not going to work well. Vector database retrieval is really fast. It's like we're 10,000 like pages of PDFs, like, and these pages are pretty chock full. It doesn't take long to query them at all. And so like even with doing like we tested on like it sounds like a small data set, but like we're building up, it's like 5,000 rows, and like that only takes like to do all 3 agents like a couple of minutes, like 2 or 3, and that's going through and like running like thousands of queries to this like vector database, and all that stuff is actually like pretty fast. We use Pinecone specifically, so if anyone wants to play around with agents or RAG, like Pinecone's pretty cool.
Have you found if you throw a whole bunch of unrelated documents at it, does it kind of dilute the performance?
Yes, that's something like, yeah, we ran into that earlier, and that kind of like, that posed the problem for us is like, the big challenge is like, when does the agent, what percentage of like consideration is the agent giving these documents versus its own knowledge? Like at first, it was relying so much on its own knowledge and ignoring the context documents, and then you tune it, and it's relying way too much on the context documents. And so the way we're approaching it now is like, it's all decision making. It's, you have one agent make a decision whether like a piece of context is relevant for whatever decision you're trying to make. You have another agent, you just have a judge judging that decision. It's just a lot of decisions, a lot of checking these decisions, and you get like the best result when you have, again, all these little segmented agents that are all working together. If they can do their individual job really well, you can build a system of them that can do it pretty well.
Thanks.
Yeah, thank you. Any other questions? Going once, going twice.
We have a question here.
Yeah.
Come on there. Okay. How do you control all the agents? Is there like a manager agent that tells when other agents when to run, or do they all kind of work on the data set at the same time?
Yes, so it's a little bit of both. They are a lot of times running like at the same time, like synchronously. And so you have an orchestrator agent, that's the top level. Entry is orchestration, exit with the revised data set is coming from the orchestrator agent. That one controls all these tiny little agents that all have their own jobs. And like we split it up into like processes. Like one process is like determining a feature that would be, that you could confidently implement based on the features you have. Like that's an individual process. There may be multiple agents involved in that, doing all little jobs. And all these agents have like a ton of little tools they can use. And tools are essentially just like functions that an agent can run whenever it thinks it needs to. And so you'll have a function for like a tool for getting all the columns from your pandas data frame, something like that. And yeah, so that's kind of like how the system of all that comes together. Does that answer your question?
Yes.
All right, perfect. Anybody else? All right, if there's no one else, I guess I will call it there.
No, whoa. You are not going anywhere before we give you a nice set of applause. So please.
Appreciate the silent thumbs. Yeah. Yeah, you guys have been a great audience. Amazing questions. And like honestly, like I actually definitely took away a couple of really good ideas from that. So you benefited me as well. I appreciate that.
Thank you so much. That was a great talk.